Hello everyone and welcome to another video. I got this little ZX Spectrum 48K a few months ago. It was a faulty unit from eBay and I managed to fix a lot of stuff. The membrane, the lower RAM was faulty. Apparently there was a problem with power, so a couple of transistors were also faulty. Several things. The faceplate doesn't look right. I did the composite mode also. The faceplate is not exactly in the best condition you can find, so I'm gonna keep this for myself for the lab to conduct all the tests that I need. Apparently this is working ever since, but I had a problem with the picture quality. The picture was not great, and I believe it was something that something that has to do with power. After all, I don't know if bad cap or more, or every cap or filtering the voltage fails or something. It used to have a couple of transistors that were off, so maybe other components have been damaged as well. So here is a recap, a quick review of everything that I've done so far. Back in the day, I changed the voltage regulator, the classic 7805 that used to be there with a big heatsink. Produces a lot of heat. It's gone. It's not here anymore. I put the DC to DC inverter, the modern DC to DC inverter here. Produces no heat, and it's reliable and stable. I found out there was a problem with RAM, so I have removed all the chips and put sockets in order to start checking the chips individually. I cut off the power for the TV modulator, and instead I made inside the box the composite mod, and then I have put on the new modern and reliable kind of membrane that you can find these days. So we have completely fully functional keyboard. Then back to the RAM, the lower RAM. I have damaged several chips as I was trying to figure out what is happening. Then I placed the order for the lower RAM module, the one that you've seen, and it worked just fine. This is a 6A version of the PCB of the Spectrum. I found out there was no sound, so I changed the TR7, and of course all the damage came from TR4 and 5 here. Usually what happens is if you have, let's say, switched wrong polarity, I bet the previous owner have experienced something like that. Quickly the damage travels all the way from the transistors to the lower RAM and blows away several chips. So first thing to do is good practice to put the DC to DC inverter and check the caps. This is what we are going to do today. We're going to be changing the caps stage by stage: the power stage, the RAM, lower RAM stage, and the video part of the PCB. Those two should be changed as well, but we're going to do it bit by bit, and we're going to conduct a test in the meantime. Those two are capable of filtering the power to the lower RAM chips, in this case the RAM module. Several other miscellaneous capacitors around here for the upper RAM, and the voltage needed for the loudspeaker, along with the transistor which drives the loudspeaker, this TR7. But I always start with those two next to the lower RAM, and the video ones right there far left. So let's start with those. But just before we can start, here is the picture that we have so far. Before we do anything, you can clearly see ghost lines, images that indicate there's something wrong with power. At least out of my experience. So I should try maybe to go ahead and try another power supply. Maybe the distorted image comes from the power supply after all. And so I changed the power supply with another one, again original Sinclair, and I think it's even worse now. I think we have waves and ghost images, and the picture is even more distorted with this second original power supply. So it cannot be that both are faulty, so I think we should try to recap after all. A great source of information is a Spectrum for Everyone website. I'm going to put the link down below, so make sure that you have seen which is you have already confirmed which is the issue of the PCB for your Spectrum. In this case we have 6A, issue 6A, and we have a list of the electrolytic capacitors needed right here. So make sure that you have all the tools needed and all the parts, the components that you might need before you start performing the operation. One of the things that everybody has some difficulty to find is the axial type of capacitors. So I got everything that I need here, but it's not axial. I couldn't find axial components like those ones from 1982. I don't know why everybody's short. I mean, I checked my local Radio Shack and they couldn't find any. I guess this kind of vertical kind of capacitor becomes a standard after all. But I got all the things that I need, the values. I tried to find the right values, but to work with tolerance over greater voltage. So in this case we need 16 volts or 10 volts or something, and I managed to find the right values to work with 65 volts, 35 volts, 25 volts, greater tolerance. In any case, those are old but good enough salvage from other Spectrums, but I'm not going to use any of those. And if you have any spares like this from old Spectrums, even though you have tested the capacitors and kind of looks okay, well, try not to use those. Just as my suggestion here, try to get new parts, new components, and try not to mix them up, old with new. I mean, so we're going to remove those two for the video circuit, and those two, first of all, those two next to the lower RAM section, in this case the lower RAM module, and start with those two. And every time we should check what is happening and what kind of picture we get. And so here is the reason why I strongly suggest you start always with those two capacitors next to the lower RAM section. We have a great picture already. I mean, it's like printed paper or something. It's great. We managed to find the faulty ones first try, and it feels great and it looks great. So what we've done so far, and we got this great result, is to replace those couple of capacitors next to the lower RAM section, and you can see the difference. You can tell how great the picture is already without going even further, recapping the rest of the machine. So those two right over here have been placed next to the lower RAM module, and you can tell the difference first try. It's up to you how you are going to bend those capacitors and how to install them. What I have found, again out of experience, is if you bend the positive leg, so it can make it to the other way, all the way to the positive part of the circuit. It's easier to identify the component data written on the capacitor, so you can try yourself and bend it the way you like, or the way you feel more confident how to do it. Those two capacitors already have shown that we got great picture already. We won't stop, because again, this is my suggestion, we should replace every capacitor on the board and try not to mix them up again. Okay, next stage should be those two, 25 and 65, on the very far left side of the PCB, and I have replaced those already, and I bent the legs the same way I did it before with the other two next to the RAM. And again, in the meantime, I have desoldered those two on the power section, far right, this time, and you can clearly see this one is already leaking some liquid or rust or something. So even so, you see how capacitors can be tricky over time. Although the machine works great, we've seen the picture before, we checked the picture before, even so, over, I don't know, a day, a week or a month, this is going to give us trouble. So that's why this, especially this part, the power supply, the internal power supply section, is essential to have the caps replaced as well. And so this is going to be the third section that is going to have its capacitors replaced. So let's take a look at the screen. I guess we have the same great picture like before. So we're doing fine, we are progressing, and we have already replaced what, 3 stages: lower RAM, internal power supply, and video circuitry with new capacitors. Yeah, those two are the ones that have been recently replaced. Internal power supply, those two should follow, or maybe I can go over to those two, the one for the transistor driver to the loudspeaker, and the other one that filters the power to the upper RAM, and all the blue ones should be gone by the end of the day. That's the plan, and have them replaced, and then I can sleep better at nights, future-proofing the machines like this Spectrum, which apparently I have decided to keep it for myself. And yeah, let's see how this goes. Let's go on with those two next to the loudspeaker and next to the upper RAM section, and we'll be checking the picture quality once in a while, every now and then, after replacing more caps. Come on, focus. And I believe that the problem has been solved since we have replaced the first ones, the very first ones next to the lower RAM already. So let us call it stage number 4 at this point. The one capacitor for the voltage filtering over the upper RAM has been changed, another one from the internal power supply, and a couple of those two, one on the main rail for the voltage to the RAM, and the other one next to the TR7 here, which is filtering voltage for the loudspeaker driver. So we have progressed even further. I think we need just a couple of more to go. This blue one in the internal power supply section, and the other one next to the ULA. And I think we're going to be good. One of the major questions that I need to answer from time to time, questions that I find in the emails or messages or whatever, or over the internet, is how long is the average life? What's the average life for an electrolytic capacitor? Low voltages, we're talking now, like these ones. And so there is no average life, because every manufacturer has its own way to make the components. And so if we really try hard to answer this question, could be 15 to 20 years on average. But again, this is not certain. For example, we have replaced those two caps next to the lower RAM, and we had a great picture, great result already. So supposedly we could avoid all the fuss to change all the rest of the capacitors, but you never know when the capacitor hits, right? So even if it comes from 1982, it doesn't mean that it will last for 40 years on average, because this might be an indication that the machine has seen limited use. That's why it can last for long. This last part, I have found a very slim heatsink to be placed on top of the ULA, and I was looking for those, because if you try to install a heatsink the regular size, then the upper case or the keyboard wouldn't fit, right? Another idea you might find useful, and I hope you find it useful, is to get a connector to your original Sinclair power supply, reverse the poles and make another connection, so you have two connections coming out of the power supply with reverse polarity. Then you can drive another computer like the Auric, and don't forget that the polarity, the one that is being used for the ZX Spectrum, also works on Commodore 16. That's also something you might find useful. And then I came up with another idea, because there are no pads for the Spectrum. I can see there is some adhesive material left from the past, but there are no pads, rubber feet at all. So I found this, which is some adhesive material that is used for furniture. I'm going to try to cut little pieces and put them over there, but first I need to clean the old glue that is still in place, and I think it's some kind of cellophane tape that was holding the, something like cellophane tape already, used to hold the feet in place. So I'm going to clean the this adhesive material. I'm going to remove the cellophane tape, clean it with alcohol, and cut a few pads to be in the place of the old ones, like the old rubber feet, so the Spectrum remains stable. That's my idea, using this kind of material. I wish it was black instead of brown, but I can use a permanent marker to make it black. After all, what matters now is that my Spectrum has feet to be stable on the table, on my desk, while working or playing or whatever, and so I'm quite happy with it. And one of the things that really I was really looking forward to testing it was the sound, and apparently we have sound. We can hear the loading sound already as this program is loading, just because it gave me trouble with the speaker, the TR7 transistor in the past, and so I just wanted to make sure that the sound still works, and apparently it does, and I'm very happy and pleased with it, not to mention the quality of the image. And for those of you have been wondering, yes, Spectrum can handle, can display, and can process 3D images like this. So we have nice picture. Now we have great ZX Spectrum 48K with new capacitors installed. I believe that this is something that is one of the first things we should do in order to future-proof our beloved Spectrums. And so I'm very pleased. I'm very happy again. It was a great Sunday afternoon recapping the old Spectrum. I'm very also impressed with the ability to display and handle 3D objects like this one. I haven't loaded this demo before, ever. And so yeah, I think it was quite fun, quite impressive, quite useful. I hope you found this useful, and if you like this stuff, the 8-bit retro machines and computing from the past, just give us a thumbs up if you will. Consider subscribing, and I guess I'll be catching you hopefully soon, if time permits, with another video, another review, another demo, or some sort of repair and restoration from the past. And I want to thank you all very much for watching and supporting this channel. Again, don't be afraid to tackle it. Recap your old Spectrum or your old system. It's gonna be working for many years ahead, like it used to be since the 80s until now, and from now to I don't know when, but it's up to you to decide how and when you're going to restore your old system. Thanks for watching. Bye.